Okay, so we're now in recording mode, and much of what we're going to be doing for the next few minutes should look familiar. The only difference should be the way in which we measure the angles. Remember that we've shifted our measurement scale from degrees over to radians, right? So my x-axis now for drawing the sine and cosine function is not 30, 60, 90, 120, that kind of thing in degrees. It's now in radians. And what I've done is I've used increments of pi over 4. So each of these blocks for the graph that you're looking at is pi over 4. So that's this pi over 4, which is what we used to call 45 degrees. This is pi over 2, which is used to be 90 degrees, and so on and so forth. Now, normally if I was in a regular in class, I would give you the table of values like this and ask you to fill it in and then use the table of values to draw the graph. But because we're in this online environment, I thought I would just go ahead and show you the graph and just talk a little bit about some of the things that you should have learned in grade 11 about these graphs. Here are some terms. I'm going to grab my stylus here. Here are some terms that you should know. One of them is amplitude. Does anybody have a definition of that? And can anybody also tell me what is the amplitude? Oh, by the way, the red line represents the sine function. So let me color code that and label that. So the red line, oh, that's not color coded at all. Let's try that again. This red line represents my sine function. And the blue line represents my cosine function. Okay, all right. Now, let's talk about some terms that you should have learned in grade 11. Amplitude. Before you give me a definition, can you tell me what the amplitude of this sine function is? Anybody, you can put it in the chat and we can talk about whether it's the same for cosine or is there a different answer for cosine. Let's start with sine though. What's the amplitude of that sine function? Hopefully you can see it big enough. I can make it a little bit bigger. Let's see, view, zoom to maybe, zoom to maybe 120. Oh, that's making it smaller, Mr. Count. Let's try that again. Well, looks like it was already as big as I could make it. Okay, so there's your function. What is the amplitude of that function? Anybody? Roma says 1 with a question sign, so he's not 100% sure. And Christiania also thinks it's 1, right? So how do we, by the way, you're both right. You're both right. How do we measure that? How do we actually figure out what the amplitude is? So they're both right. Both Roma and Christiania are right. Can anybody tell me how we would measure that amplitude? So I'm going to put that amplitude right now in this little box here as being 1, right? That's for the sine function. How do we measure that though, right? How does that red line qualify for having an amplitude of 1? Does anybody remember how we calculate that amplitude? Highest point minus lowest point divided by 2. Max plus min divided by 2. Well, those are two different definitions there. Hussein and Roma seem to be saying two different things. One says you subtract them, one says you add them. So who is right and who is wrong? You can't both be right. So who's right and who's wrong? Who agrees with Roma? Let me start with that. Let me do a quick poll here. Who agrees with Roma? Anybody agree with Roma on that? She says highest minus lowest divided by 2. Okay, so Roma, not a lot of agreement there. Hussein, oh, so Muhammad agrees with Roma. How about Hussein? Hussein says it's max plus min divided by 2. Who agrees with Hussein on that for getting the amplitude? Anybody agree with Hussein on that? So Chrisani agrees with Hussein on that one. Oh, it looks like Hussein. Wow, Hussein getting a lot of love from the room there. That's good. So although it's good, I have to tell you, I'm not sure how to do this nicely. Okay. It's actually the other way around. It's actually the other way around. It's actually the answer that we got originally from Roma. It's highest minus lowest divided by 2. So it really is the distance between the high and the low, because that's what highest minus lowest gives you. The distance between those two. How far is the high from the low, right? Think about the high. The high on that red line, the sine function, is at 1. The low is at -1. So if you think about a number line and you go from +1 to -1, you've traveled a distance of 2. And one way to get that distance is not to add those two things together, it's to subtract them from each other. So I would have 1 minus -1, which is the same thing as adding it. So 1 plus 1, which is 2. And then divide that by 2, which is what they both said. They both said divide by 2. And of course, the amplitude is 1. Okay? Let's get to the period of the function now, right? Look at the graph. Look at the graph very carefully, right? Try to remember again from grade 11 what period meant in the context of a sine or a cosine function, or in fact, any trigonometric function that had a specific meaning. So before we get a definition, can anybody tell me what the period, the red line, we're focusing on the red line now, the sine function, what is the period of that red line, of that sine function? Just look at it for yourself, right? And try to remember what the definition of period is in this context. And tell me what you think the period of the red line is. Anybody? Anybody? Chrisania says 2 pi. And Mohammed also says 2 pi. Lian says pi. All right. Are there any other answers? Or who, I mean, are we, the consensus seems to be 2 pi on this. By the way, Leon, did I mark you present? I did not. Leon, I see that you're now here. So I don't think you told me you were here. All right. So let me put you as being here, but you got to let me know when you enter, if you weren't here when I did the attendance. Okay. So 2 pi is correct. 2 pi is correct. So why is it 2 pi? What is the way that the length of one cycle? Good. So now we're not measuring how far it is from the high to the low. That's the amplitude. Now we're measuring, and that's a vertical distance, by the way. We're measuring vertically how far we are from the high to the low. What we're measuring now is a horizontal distance. How long does it take to complete a cycle? So one way we can do that is to pick 2 points on the graph, and I'll pick maybe this point right here, and I'll pick this point right here. Those are 2 high points. Find 2 high points on the graph, 2 highs, right? And subtract them from each other. That's one easy way to get the period, the length of the period, because that's a cycle. If you go from one high to another high, that'll be a full cycle. Right? Now, another easier way to do this particular graph, I'll just circle 2 green points here, is from there to here. So where it crosses through the center line, right? That distance going from 0 to 2 pi, that will be one cycle as well. Now, notice I didn't go, there's another place where it crosses through the center line right here, but I didn't use that one. In fact, let me undo that, and let's put that in a dotted line. Right? Why didn't I use that as a full cycle? Well, I'll tell you why I didn't use that. Right? I didn't use that because it's not a full cycle yet. If I started at green, which is where it crosses the center line, by the way, is the x-axis. If I start at that first circle and go to that purple dotted, not purple, or pink, or whatever it is, to that point, I haven't yet completed a full cycle because I've only gone up to the high. I've gone back to the center, but I haven't gone to the low yet. So I need to complete a full cycle going from the first point where it crosses the x-axis, right to the origin. So it's on its way up to another point where it's on its way up again, which is at 2 pi. So I completely agree with the answers that we got. I think the first person who gave us that answer was Chrisania, and a lot of people agreed with her. So that's great. All right, so the answer to that is in fact 2 pi. Now, let me erase some of this stuff here on the sine function. And let's ask some of the same questions now for the cosine function. Cosine function. That's the blue line. That's the blue line. What would be the amplitude of the cosine function. Now that we've discussed how to get the amplitude of the sine function, we should now be in a position to say what the amplitude of the cosine function is. Anybody? Cosine amplitude of the cosine function. Can anybody give me their best guess at that? Remember, we said it was the high minus the low divided by 2, or distance from high to low divided by 2. So a bunch of people are saying 1, and the answer is, of course, 1. All right? It's the same distance of 2 from the, oh, sorry, let's fix that. It's the same distance of 2 from the high to the low, right? The high is at 1, the low is at minus 1. Distance between those is 2, so 2 divided by 2 is in fact 1. There you go. How about the period of this function, right? Is it any different from the sine function? Sine function had a period of 2 pi. How about the cosine function? Look at the cosine function now. And let's see if you can come up with a period for that function. So Leanne is saying it's 2 pi, and Donna and Hussein are all saying the same thing, and you're all right. So 2 pi would be the period. And again, I can choose 2 high points. So here's one high point right here. There's another high point right there. The distance between those 2 high points is 2 pi. And I'm measuring the distance horizontally this time. From one high point to another high point going horizontally, that's what the pi is. 2 pi is. Yes, Alexander. Okay. All right. Joshua, let me call on you again. Are you with us? No. All right. Is Joshua with us? No, let's see. Is Joshua even logged in? He is here. Yes. So Joshua, are you there? Okay, good. Make sure you stay with us today. Okay. So there's your sine function. There's your cosine function. You didn't have to draw it this time. I'd already drawn it for you, and I just wanted to go over some of the main features. You'll notice that the graph tends to go through these cycles. We have some other features that we need to talk about, but let's just leave it at that for now for graphing the sine and the cosine function. Let's get to the tangent. So the tangent, remember, is the sine divided by the cosine function. That's really a rational function. And if you remember rational functions, they tended to have vertical asymptotes. There are points at which the graph is undefined. So I would think if I'm dividing by cosine, wherever cosine is 0, I should probably have a vertical asymptote. Just trying to relate this all back. How do you calculate for amplitude again? Okay, so Sindhuja, thanks for the question. That was Sindhuja's question. And I'm just repeating it because I'm not recording the chat or recording anything that people ask verbally. So to calculate the amplitude, we take the high minus the low and divide it by 2. Okay, so high. So in other words, the distance from the high to the low divided by 2. All right. Another way to measure it, by the way, just so you know, is to go from the center line, which we're going to talk about some more, from the center line to the high, or from the center line to the low. That also gives you the amplitude. Okay, let's get to this one. Again, you're not graphing this yourself. I'm just going to show you the graph so you know what the graph looks like. And I was just talking about the fact that this graph has some vertical asymptotes. Why is that? Well, there's a good reason. Sine divided by cosine is what tangent is. Those of you who are with me yesterday or who have since watched the video of the trig identities know that the way that you calculate the tangent of an angle, you could use the y over the x coordinate. We talked about that. But if you take your sine value and divide it by your cosine value, that's your tangent value. No, because it's a rational function, anytime the denominator is 0, this thing becomes undefined, and then you have a vertical asymptote. So let me just go back for a second here and look at this cosine function. This cosine function was 0 at pi over 2, at 3 pi over 2, at 5 pi over 2, at 7 pi over 2, and so on. Those are all the places where the cosine function was 0. As it turns out, those are all the same places that the tangent line has a vertical asymptote, because at that point the sign is 0. You try to divide by 0, it's undefined, so you get a vertical asymptote. So this is what the tangent function looks like. It's broken apart because of the vertical asymptote. It's not a continuous line. You know, like when we were drawing the sine and cosine function, we had a continuous line. That's not the case with a tangent function. It breaks apart. No, let's talk about the period of this function. Remember, period is how long does it take to complete one cycle. So I want you to look at this and tell me if you can figure out what the period of this graph is. All right, leave that to you. Come on, folks. You tell me, what is the period? Okay, Thomas says it's, Chrisania says pi with a question sign, so she's not 100% sure. Thomas says it's 2 pi. Who is in the Chrisania corner? Who is in the Thomas corner? Let me I like to do a little poll of the room here. I'm not saying that either of them is right. They could both be wrong, but I'm just asking for who agrees with who. Thomas says, wait. Okay, so he's not so sure. So Donna says it's Thomas, but Thomas is reconsidering. Okay. So anybody want to go with Chrisania? Let me start with that. Anybody thinks this could be pi as the, remember, we're talking about the period now, right? So Lynette says yes. Thomas says that he's going to go with, okay. So Thomas, you're saying stick with the 2 pi. So Lance is 2 pi. Roma has gone back to pi. All right. So Roma is on the Chrisania bus. All right. So who is right, who is wrong? Or is there another answer? That's the question we have to deliberate here. All right. Okay. So a lot more pies are coming in. Well, let's look at this. One of the things I said to you is, how long does it take to complete a cycle? So it would seem as if the tan graph starts its cycle somewhere, let me put this in red, somewhere down here, right? And then it completes the cycle somewhere up here. Then it starts the cycle again somewhere down here. Then it goes up to the top again, somewhere down here. So the question is, since the cycle all takes place within these vertical asymptotes, how far apart, here's the question, how far apart are these vertical asymptotes? So if I took one vertical asymptote, which is pi over 2, and subtracted it from the other vertical asymptote at 3 pi over 2, how far apart is that? Or if I took the 5 pi over 2 and subtracted the 3 pi over 2, every time you're trying to find a period, what you're doing is you're seeing how long it takes for you to go through one cycle and then repeat yourself. A lot of pi's are coming in now. So in this case, I'm going to take the 3 pi over 2 and subtract from it the pi over 2. Or I could take the 5 pi over 2 and subtract from it the 3 pi over 2. Right? As long as I'm subtracting two adjacent vertical asymptotes, I should get the answer. Well, luckily for us, it has the same denominator. Right? So it looks like it's going to be 1 minus 3, which is 2 pi over 2, which of course is just simply pi. It's the same thing here. It's 5 minus 3, which is 2 pi over 2, which again is just simply pi. So there's your answer. So I'm going to have to jump on the Chrisania bus on this one. She was the first person, I think it was Chrisania who first said that it was, let's see, yeah, Chrisania. Although she said it with a question sign, so I don't think she was so sure. But anyway, Chrisania was the first person. Yeah, I forgot the denominator. You're right. Okay. So, I see what you did. You subtracted it, but you forgot to divide by 2. Okay. So there you go. So there's your period of the function. The period of a tangent function is actually pi. Now, restrictions. What values of the angle are restricted? Give me one example of a restriction for the tangent function. Right? Can anybody think of what x cannot be equal to? If x represents your horizontal axis, x cannot be equal to pi over 2. Absolutely. Let me put that down here. But obviously that's not the only one, because we talked about this a few minutes ago. Another one is that x cannot be equal to 3 pi over 2 and so on and so forth. Now there's a way for you to write that out so that you can generate every single possible restriction, but I'm going to leave that for another day. Okay, so x cannot be equal to 3 pi over 2, x cannot be equal to 5 pi over 2, x cannot be equal to, and so on and so forth. Those are all possible restrictions on x. All right, this does not, let me just say something before we move on. This does not have an amplitude. right? This does not have a high point. It is going towards infinity as you get close to the asymptote, right? As it is with most vertical asymptotes. It trends towards infinity. So there is no high point. Infinity is not a high point. So you cannot define an amplitude for a tangent function. Just cannot be done, right? Hussein, you're right. 3 pi over 2 is also possible, and 5 pi over 2. Those are all possible restrictions for the tan function. Okay, so we have an idea of what the sine function looks like, the cosine function looks like, the tan function looks like. We also have an idea of the definition of period and amplitude. Let's get to the next important thing that we have to talk about, which is writing the equation for one of these functions. F of x equals a sine k x minus d plus c. That's considered to be the general sort of format for writing one of these functions. Now, what I need to do is to open up a Desmos graph and walk you through which, well, you know what, in the interest of time, rather than me going to Desmos, I'm going to stick with this one. Let's see how much of this you remember. Does anybody remember what part of this will give us the amplitude? So there's an A in the front, there's a K inside one bracket, the square bracket. Then there's a D that you subtract from the X, and then there's a C on the end. Does anybody remember what part of this equation gives us the amplitude? Does anybody remember that? The A is the amplitude. You're absolutely right, Hussein. That's absolutely correct. So I'm going to write that on the bottom here. The A is always going to be the amplitude. But I want to warn you that that A can be negative sometimes, which does not mean that the amplitude is negative, right? You do not have negative amplitudes. You might want to write that down somewhere. The A will give you the amplitude, but it is the absolute value of the A. Absolute value means regardless of whether the A is positive or negative, it's the number that you get that gives you the amplitude. So if you have a negative 6, amplitude is 6. If it is a positive 6, amplitude is still 6. Amplitude is never negative. Okay. Do we know what gives us what part of the function will influence the period of the function? Looking at the equation, does anybody know what part of that function gives us the period or leads to the period of the function? Right? Again, I'm hoping that you're remembering all of this. We don't want to have to go through. Okay, so Lynette is saying what Hussein is saying, and Sindhuja is also agreeing with Hussein on this one. Does anybody have a different answer? No? Okay, so is K the period? Does K actually give us the period? Is that the way this works? I may have to fire up a Desmos graph in a second. Does K actually, is the K the same thing as the period? Do we know? Or does it just allow us to calculate the period? Does anybody know the answer to that? Prisania says, no, it's not actually the period. And you're right. In fact, you know what I'm going to do? Let me actually fire up a Desmos graph. So I'm going to stop sharing